Welcome. Today's live is on CRISPR. So what is CRISPR? Well, CRISPR is an acronym, but what CRISPR does is it is a genetic cutting tool, a pair of scissors. And these cutting tools, this pair of scissors, is on the horizon of changing the face of genetic-based diseases. So what's so important about this? In 2020, for us it's last year, Doudna and Charpentier won the Nobel Prize in Chemistry for their discovery of the CRISPR-Cas9, which is a gene cutting tool. This tool has already been used in 2019 in the US for a woman to correct her sickle cell anemia. And that's a genetic disease where red blood cells are built differently. The shape of them is different, and this affects how well they deliver oxygen in the system. So since the dawn of time, bacteria and viruses have been at war. And viruses are a floating piece of genetic material, and viruses can insert themselves into the cell of another living organism and then take control of that cell and replicate themselves. So bacteria get sick also, but they have developed a way to protect themselves by keeping a tiny piece of the virus's DNA inside of their own DNA in a segment called CRISPR. So when the bacteria gets exposed to that virus again, they make a copy of that piece that's stored in the CRISPR, and it attaches a protein called Cas9, hence the reason for the CRISPR-Cas9. And then that little combination goes looking for the matching segment of the invading virus. And when they find it, they use an enzyme to chemically snip that piece of virus DNA out and cut it up, and that destroys the virus. And because this information in the bacteria is kept inside their DNA, that little piece of code is passed on from generation to generation. So it's like a viral library that bacteria keep. So as the bacteria breed over the millennia, they've got this little library, and if they get exposed to a virus, they can go in, find that bit of DNA and cut up that virus. And this is what this CRISPR cutting tool is. So that's great for bacteria, but why did that discovery justify the Nobel Prize? Well, animals and plants have more sophisticated immune machinery, and when our DNA is broken, we can join it back together, or we can insert a new piece of DNA where the break is. So as it turns out, this CRISPR snipping tool can be programmed to look for an exact piece of DNA, create a break, and insert a new piece of code. For example, looking for the known piece of DNA code in humans that creates a gene mutation leading to sickle cell anemia, as happened for that woman in the USA in 2019. But not just sickle cell anemia. Also, investigation is now being looked at for muscular dystrophy, childhood blindness, cystic fibrosis, all of which have a gene mutation that creates disease. So, the science is being undertaken at the moment in animals and plants, and there are various companies looking at using this cutting tool, this CRISPR tool, to create health in people through cutting out a wrong piece of code and inserting it a new piece of code. So what happened to this woman in the USA? Well, what they did to correct this code was to take 2 billion of this woman's own bone marrow cells that create red blood cells and change the code in that, and then reinfuse her with those cells. And 12 months later, she barely had any signs or symptoms of the disease that had crippled her for the entirety of her life. So you can see the power of this new science in treatment of genetic conditions which cause so much suffering. And it's expected that in some form this will be part of scientific trials or as medicine by around 2025, according to Doudna, one of the the awardees for that Nobel Prize. And if you want to know a little bit more about CRISPR, then go and check out Doudna's TED Talk, How CRISPR Lets Us Edit Our DNA. All right, bye for now.